Okay, rusting. Very quickly, and then you've got a couple of sheets to do on rusting. Rusting is a real-life application of a redox reaction. Okay? We don't like it, but it happens spontaneously for us. Spontaneously, iron becomes iron 3+ by losing its electrons. Okay? We don't like it, but it does it. So the metal iron becomes ionic compound, iron 3 oxide. That's simplified. It actually becomes a mixture of iron 3 oxide and iron 2 oxide. And that compound is hydrated. You know that whole dot 6H2O? It's also that. So it's a bit more complicated than this simple, right? We're simplifying it a lot for us. So how? The formation of an ionic bond from atoms involves the transfer of electrons. Iron atom loses 3 valence electrons to become Fe3+, like this. Ta-da! Leo or Ger? Leo. So oxidizing agent or reducing agent?
Reducing.
So iron is a reducing agent because this is a oxidizing half reaction. Everybody okay with that? At the same time, oxygen, actually it's not really just oxygen, it's oxygen and water, but hey, we're simplifying it, is going to gain 2 electrons. So there you go. O atom gains 2 electrons, so O2 element gains 4 electrons. We've gone through that quite a lot in the diatomics. I'm skipping over this, so you get this half reaction. Everybody okay with that? It's a gain of electrons, half reaction, so therefore oxygen is your oxidizing agent. That makes sense, actually. It's going to cause something to oxidize because it's oxygen itself. Okay, so overall, the simple equation would look something like this, very simplified. You've got, I need 7 electrons gained for every 7 electrons lost. 12. I'm multiplying. 12. 12 electrons gained for 12 electrons lost. So there you go, there you go. Yeah? So there you go, there you go. And there's your net ionic equation. Sweet. Right. We hate rust. We build things out of iron because it holds good properties. First of all, it's cheap. Second of all, it's strong. Third of all, it's a metal, so it's malleable and ductile and all those other things that you'd want when you're building a bicycle, when you're trying to stamp the city sign in the manhole cover. Okay? All those things are really important, and this is why we use iron to build manhole covers, to build stair walls in industrial buildings, to build the framework for apartment complexes. The problem is they rust, and you don't really want your apartment complex rusting. You don't even want your lovely cast iron gate as you go into your property full of rust. Look underneath your truck, underneath at the chassis, the wheel axles. Rust. We don't want things to rust. So we have a big industry trying to prevent the rust corrosion because the iron oxide doesn't hold the same properties as the iron, does it? The iron oxide is crumbly. It's an ionic compound. It's a salt. You're holding the bottom of your truck together with salt? You're riding on a bicycle with salt? Doesn't go very well, does it? And so we want to retain the properties of iron itself. So we do a few things to prevent the corrosion. First of all, this is saying you need 3 things for rust to happen. You need, the iron, you need oxygen, and you need water. So you can do an experiment. We did this experiment in Chem 20, do you remember? Yeah. To prevent our corrosion. So this one took out nothing. You've got oxygen in here, you've got iron in here, you've got water in here. This oil prevents the oxygen from coming in. The boiling took the oxygen out in the first place, and this drying chips prevent the water from coming in. So you would see no rust here, no rust here. Okay, what speeds up rusting? What's a catalyst for rusting? Remember?
Salt.
Salt. Good. Salt. Okay?
So our boats rust.
That's why boats rust faster than cars in Alberta. Except for, what do we do in Alberta? Do we do a lot of
Salt.
Right, we salt our roads. Okay, not exactly the best choice you can have. So if you're choosing what to do on your driveway on an icy day, personally I wouldn't salt. I would gravel. Well, shovel's a good thing too. Salt lowers actually raises the melting point, and so therefore it will melt it faster too, right? So that's why we like to use salt, but you want to use it very sparingly.
I know that they use salt on the roads because in BC they use like boulders, I swear, on the road. Most cracked windshields ever. So I prefer salt over boulders.
All right. Well, make sure you spray the under of your truck. Okay, so how do we prevent rust? Well, we paint, we oil, or we galvanize. Okay, so paint is obvious. Paint. But not so obvious, how does it stop rusting?
Coats it so it coats it so there's no contact with other stuff.
Very good. So it coats it so there's no contact with the other stuff, not so very good.
Oxygen or salt.
So the oxygen can't get to the iron. You okay with that? So this is called a physical barrier. Because it physically holds a barrier between the atmosphere, where the water and the oxygen are, and the iron itself. Oil, same thing. You can't paint the chain on your motorbike. If you paint the chain on your motorbike, it won't work out very well. But we can oil it, and you're supposed to. You're supposed to take the chain off and grease it on your motorbike or bicycle every once in a while in order to keep it from seizing, right? And breaking. Why does it seize and break? The rust that's forming. So if you keep it oiled, it keeps things moving. The pistons in our engine, they're oiled so that they keep moving and don't rust and seize shut either. Why don't they rust? Because you're preventing the barrier, or you're making a barrier. So the oxygen and water can't connect with the iron. Get it? Another physical barrier. So we either use paint or oil to make a physical barrier, depending on whether that part needs to move or not move. A pole, you don't need to grease it because it's just a pole, so you might as well paint it, being the stairwell or whatever, right? Okay, galvanizing is a little harder. Okay? Galvanizing means galvanized nails. Heard of galvanized nails?
Yeah.
They take their iron nail, and you love the iron nail because it's so great, because it has all the properties that iron has. And then they electrolyte, you'll learn what that is. They coat it, so as if they dip it, but not really. They coat it in zinc metal. Okay, why don't they make the whole thing out of zinc? Well, zinc's too soft, and zinc's too expensive. So it's a little bit like a silver-plated trophy. Okay? It's not solid silver, so it's cheaper. And it's hardier. Right? But it's a nail and it's covered in zinc. So the great thing about that is prevents the rust, physical barrier. Just like the iron and just like the paint and the oil. Everybody okay with that? But also, when you're hammering that nail into the wall, the nail's going to chip. Right? The coating, if it was paint, literally if you dipped it in paint and you hammered it into the wall, the paint would flake off. Would you agree with that?
Yeah.
And that happens to the zinc as well. The great thing is that the zinc is a stronger reducing agent. So it sacrifices itself, and the oxygen will bond with the zinc before the iron. So you make zinc oxide, not iron oxide. Does that make sense? And this is how they do it with ships. Only they don't coat the whole ship in zinc, but rather they just put a patch on it. That's right. And then they replace the patch once it gets to the next port.
Does it look the same as regular rust though? Well, with iron rust?
Does zinc
Yeah.
oxide look the same as rust? Yeah. No, zinc oxide looks white. Yeah. Does that make sense, you guys? Okay, so You can read all that. It says the same thing. I used the word sacrificial protection. We talked about boats and lumps bolted on. It's all there. All the blah blah I just said is all there in note form for you. Okay. So, an unwanted voltaic cell. We're going to learn what a voltaic cell is later. There's just a summary, I guess, I did. Is this a summary? 1, 2, 3. Oh, look at that. A ship with a patch on it. Okay. Or, I said zinc, but it's zinc or magnesium normally. Okay, so zinc or magnesium both work. Right, so there you go. A worksheet on iron to practice the half reactions, the things that are needed on a sacrificial anode bit.